Sentry helps you prioritize the performance problems that directly impact your end users. On the browser, core web vitals are key metrics that represent the overall quality of the user experience on your web pages. Today, we're excited to share that Sentry now has support for the latest core web vital, INP. INP, or Interaction to Next Paint, measures your application's responsiveness to user interaction. It takes the latency of nearly all user interactions on a page and reports the worst one. With over 90% of user time spent on a page taking place after the initial page load, measuring and improving the performance of user interactions is critical to improving the overall experience. We didn't stop at just showing you your INP metric. We've built an entire workflow to help you identify the associated element and interaction type, then to get you to the code causing poor interaction performance using profiling. Let's take a look at an example. We're constantly using Sentry to build Sentry, so let's see how things are looking for us in production. As you can see, INP is now part of the overall Sentry performance score. We can also focus solely on the INP component of this score and see how we can improve our application responsiveness with it. Clicking on that component, we can monitor INP performance over time. There's also a list of pages within your app ordered by the highest opportunity, which measures how much the INP of that specific page contributes to the overall INP score. For this example, we're going to look at our Discover homepage, where users can query their Sentry events using a range of custom filters. We can see that the INP opportunity score for this page is quite high, which means there's a lot we can improve here. Clicking on the link takes us to the page overview with a list of samples, each representing a single user's experience of Discover. On this page, we can see there's a range of interaction response times. Let's look at an example of a slow interaction by opening a replay. As you'll see, when the user clicks a button on the page, it takes up to 3 seconds for the modal to load, which is why our INP is so low for the user's experience of our Discover homepage. Now that we know the issue, or the what, we can actually go back to the Web Vitals workflow to determine the root cause, or the why, using profiles associated with each sample. Each profile collected in production from the user's browser can actually show us how long JavaScript code took to run at a function level. By identifying slow functions, we can find code paths that impact INP. The timeline at the top represents spans, the various operations that can take place when loading or interacting with a page, including resource loads, API requests, and user interactions. For our example, we can see a UI interaction click span with a duration of 3 seconds, equivalent to the user clicking on the button we saw earlier in the replay. Looking below the span, we can see the call stacks for code executed during the span. Specifically, there is an on-click frame that calls compute modal placement. We can see that getBoundingClientRec gets called many times sequentially within this function, which is why the user's interaction is taking so long to process. We can probably fix this by optimizing compute modal placement to not call getBoundingClientRect so frequently. Alternatively, we can update our code to yield the main thread between each call so we don't block rendering or other interactions from occurring. Now that we know the root cause, hovering over compute modal placement shows us which line and file the code is called from, so we know where to apply our fix.